Hello friends, today we are going to see the concept called thermal forces. Thermal forces part 2. Right? So in last class we have seen, okay, so this is the stress diagram. So we have seen how to calculate tensile stress and compressive stress, okay, in the LWR track. But now question is whether we have only tension. Okay, LWR track was subjected to only tension, only compressive force, or both tension and compressive force. So that's what we'll see in this video, right? So before understanding, now I have told you that when temperature rises you will have compressive force, and when temperature falls you have tensile force. So how we were saying, so let us understand. Say you have a, let us say this is the track, okay, and this is the ballast, okay, longitudinal ballast resistance. Now when temperature increases, track want to expand, but this longitudinal ballast won't allow it to expand, and it will start applying a force like this. So it start applying a force like this. So now this force is called compressive force. So when temperature increases, compressive forces are developed inside the track. Now suppose you have a track like this and you have a longitudinal ballast like this, right? Now when temperature falls, track want to contract, but this longitudinal ballast resistance won't allow it to contract, so it will start applying this tensile force. Alright, so because of this tensile force on the rail, right, this tensile force applied by the track, applied by the ballast on the rail, longitudinal ballast resistance, okay, you are saying that when temperature falls, rail was subjected to, LWR track was subjected to what? Tensile stresses, subjected to tensile stresses, right? So it is clear, right? When temperature rises, compressive stresses are developed, and when temperature falls, tensile forces are developed, right? Now next is, so just now I have told you when temperature rises above TD, like TD plus 10, TD plus 20, TD plus 30, so on, you will get what? Compressive stresses, right? So what this compressive stress will do? It will cause buckling, okay, because of excessive compressive stress developed in the track, there was buckling forces developed in the track, right? And what this buckling will do? Buckling will disturb the alignment. So you have a track like this, and because of buckling forces you will have like this, okay. So now train can't pass like this, so there was immediate derailment because of compressive stress, right? Now what this tensile force will do? So we have seen that when temperature falls below TD, like TD minus 10, TD minus 20, TD minus 30, and so on, right, you will get what? Fracture. So due to excessive tensile forces, when tensile forces crosses limiting value, okay, you will get fracture of track, right? So what fracture means? So you have a track like this, and because of tensile forces, okay, there was crack developed inside the rail, right? Okay, so this is called fracture. Now few trains can pass through fractured rail compared to buckling track. Now you tell me, so you have a rail like this and you have a rail like this, so this is fractured and this is a buckling. Right, now which one is more dangerous? So obviously this is more dangerous. At least two to three trains you can pass through this fractured track compared to this buckled track, so this is better compared to this one, right? So from this, what we understood, compressive is more dangerous than tensile. Compressive is more dangerous than tensile, right? So now question is, which one is better? Which one you will give more importance? Which one you will allow more in the track, and which one you will allow less in the track? So obviously we will allow more tensile stresses in the LWR track compared to compressive stresses. We will maintain as less as possible, as less compressive stresses as possible we will maintain in the track, and tensile stresses we will allow more. And we also have one more thing, like obviously tensile strength is more in rail compared to compressive strength, and rail not only takes tensile strength, it will also has some compressive strength. So but overall we understood that compressive stress should be less compared to tensile stress, right? Now next is we have to fix our TD, right? So we understood that we will have compression and tension, and this should be less compared to this one, right? So now we have to adjust our TD. TD is what? Zero stress, and whatever we speak, we'll speak with respect to TD. Now question is where you will fix TD so that you will have lesser compressive stress compared to tension, right? So that's what we'll understand. So for that we have a concept called range of temperature. So entire country was divided into zones, like zone 1, zone 2, zone 3, zone 4, right? And in zone 1 you have this much range, 40 to 50, and zone 2 51 to 60, and see in zone 4 you have highest range. So before that let me understand what is this range. So range means what? Difference of highest and smallest value of temperature. Okay, highest value, let us say highest is 60 and lowest is 20, so difference is what? 60 minus 20, 40. So this is called range. And in general term we will speak range, like say you have an antenna, you can see here, and its range is 10 kilometer. It means what? So in over the entire 10 kilometer range it can monitor, okay, it can go through and monitor. So just like that we also have range of temperature. So in our LWR track, so you have a maximum temperature T max, you have a minimum temperature T minimum. Now range is what? T maximum minus minimum. This zone from here to here, T max minus T minimum is called range. It means what? So now temperature goes from T minimum to T max, again come back from T max to T minimum, again go to T max, again come to T max. So that's how temperature will vary and create these stresses, right? So now once you see here, you got T max value, you got T minimum value. Now question is where you will fix so that we will get that compressive and tension criteria, right? So let see, first let us see, we will fix TD at a T minimum. Let us take our neutral state temperature or distressing temperature as TD, and that we will fix as T minimum. We will take T minimum. Now what will happen? So this is the minimum temperature, this is the minimum most temperature. So now temperature can't go down beyond this, right? Now it will go only in upward direction, it will only increase, it will not decrease. So when TD start rising, start increasing to go towards T max, compressive stresses start developing and it will reach highest. So in this condition, so for the entire range you have only compressive stress, so you have highest compressive stress, okay, in this condition. So we want very lowest compressive stress because this creates compressive, this is very dangerous. Next you see this, so let us fix at T maximum. So suppose we have fixed our TD as T max, what was happening? Now temperature can't go beyond this maximum value, so it has only choice that it has to decrease, right? So it decreases and go up to T minimum, right? And when temperature falls below TD, what kind of stresses? Tensile stresses are developed, and it has highest tensile stresses, and zero or no compressive stresses, okay, right? Now let us see this criteria. Now let us fix TD at a mean value, at a mean average. Now what was happening? We are not getting highest tension, we are not getting highest compression, we are getting only 50% tension and 50%, okay, tension is 50%, compression is 50%. So when we are at mean, we have two choices, we can go towards max or we can come towards minimum, right? Yes or no? So see, compared to previous cases where we have 100% compression or 100% tension, this case is better. right? So we have only 50% compression and 50% tension. So this case is better compared to previous condition. But what kind of condition we want? We want such that, so this is safer, but see, both are 50-50. So we, as tensile strength of rail is more compared to compressive strength, we can still increase the tensile stress. So if you see this condition, TD is equal to T mean plus phi. So in this condition we have more tension is more compared to compression. So less than 50% you have compression and more than 50% you have tension. So as rail has more tensile strength, so we have given more importance to tension. So more, we have allowed more tensile stress compared to compressive stress, right? So now this condition, in this condition, okay, we have lesser compressive stress and more tensile stress. So now what will happen? Now when at a TD temperature, compressive and tension is equal to 0. Now when temperature rises, compressive stress reaches to this value. Then again when temperature falls, compressive stress decreases, becomes 0. And then again tensile stresses increases, and when temperature again increasing, it will go, become 0 0 here, and then again like that. So it's like a cycle, right, which has both compression and tension, but compression is less and tension is more, right? So based on this idea, okay, we have fixed as per IRPWM. See, this how they have fixed the TD values. See, in zone 1, 2 and 3 we have T mean to T mean plus 5, right? At this temperature we have fixed the TD values, not TD is equal to T minimum or TD is equal to T maximum, but they have fixed TD is equal to T average or T average plus 5. And in zone 4 they have fixed Tm plus 5 to Tm plus 10, right? So I hope at the end of this session it is clear that same rail was subjected to compressive and tensile stresses, not just tension, only tension or only compression, right? So this criteria was clear to you. So because of that, so whatever gap we have provided, so that decreases and increases from day to, from morning to evening, right? Yes or no? So SEJ gap also keeps on increasing and decreasing with time, right? So this is because of compressive and tensile stresses both, right? So whatever stress diagram we have drawn in LWR track, see, this will have both compression as well as tension, which varies from time to time. So that's what we want to discuss. And okay friends, thank you all, thank you so much. Please do